You are welcome to Tutor Think, and thank you for joining me here. I hope you have subscribed to this channel. And in today's video, I'll be talking about the second phase. I'm doing the second part of using the integrating factor to solve for a first linear differential equation. So there's a similar question to this. This is in a different form. I've already done that. You can look at this video in the same playlist. Laplace transforms and integration. So prove that any equation of the form dy dx plus m of xy equal to n of x. And it says that where m and n are continuous function of x alone, and it has the solution this. So we want to prove that the solution for the general question will give us this. And if is the integrating factor, and it is e integral of mx dx, and c the constant of integration. So for this question, because we are proving, we need to be writing down the statement, simple statement when you are solving this in exam. So I'll put this down for you. I've already done the first one. So the solution will be in this form. First, you write down your equation, the one that was the linear differential equation that was given to you. So this is what I have here. Dy dx plus this equal to that. And I'm saying that mx and n of x are two separate functions. Once I begin to take example under this, which you will see in the examples of linear differential equations, you will get the concept. So these two functions are in terms of the variable x, and then y, and the first derivative of the variable y means that the equation is a linear first order differential equation. So in your first steps, you write it down, then you write a statement that where m and n are both continuous function of x alone. Then your next statement will be multiply both sides of the equation by the integrating factor. So I'm about to do that. I'm about to multiply both sides of the equation by the integration factor, which is what? This. So we have e integral of m dx, or you can use mx dx, times dy dx plus e integral of m dx times m of xy equal to integral of m dx times n of x. So that is what I have done. In your next step, you need to write the statement that when you look at the left-hand side of the equation, it is a derivative of the integrating factor and y. The rule behind linear first-order differential equation is that when we take the derivative of the integrating factor and the variable y, it will generate the left-hand side of the equation, this side. When you prove this using the product rule in differentiation, so when I hold this and I differentiate this, this is the result I'll get, and then I'll hold this and differentiate that, generating this equation. So you write that statement. So from the left hand side of the equation, you say that the equation is a differential of what? The integrating factor and the variable y. So this is it. So this is what we are talking about. So from this step, after you write down this short statement in your own way, you just take the derivative of this and that. So I'm about to take derivative of y e m dx equal to the right hand side, which is integral of what? M dx times nx. So that is all we have. So after you take the derivative of that, remember that when you differentiate this side, you will generate this one. So that is why we just take it short and then we equate it to the right side and we move on. So you integrate both sides of the equation. So integrating both sides, we have integral of d dx y e m dx equal to integral of e m dx times n of x dx. So that is, I've taken integration on both sides. So now this integral sign will take care of the derivative here, and we are left with this side. So let's see what we have. So this is what we have here. So the integral sign here will take care of this derivative, and we are left with this side. So when we differentiate this side, this and this will go off, and we are left with y e integral of m dx equal to this e integral of m dx times n of x plus c. So now we are done. Now the question says we should leave it in the form y equal to what? Integral of n e this plus c all over the integrating factor. So that's what we are coming to do. Okay, so to be able to do that, we substitute this integrating factor with if. So we know that if equal to this. So I'll just substitute it here on the left hand side. So y times if will give us the same result, e integral of m dx times n of x plus c. So I did not substitute it here because I want to prove the equation. There is no need. So I can divide through by if to get rid of this one. So by if here and then by if here. So the proving is done. So we can rewrite this as y equal to integral. Now let's look at the original question. This is what they are asking us to do. So n comes first because n and this are multiplying. Multiplication is commutative. So I can write this as my n of x. If you want to bring your x, e integral of m dx plus c all over if as your integrating factor. So this is it. We have proved that y is equal to integral of n e integral of what? M dx plus c. And I'm saying that this and this are two separate functions in terms of the variable x, constant of integration, and then the integration factor, which is the same as this one. So this is how we prove it. Now you can locate solutions for examples under this particular topic. This time I have substituted functions for n of x and then m of x. So look at these examples to equip yourself under linear first order differential equation. Thank you for joining me here. Please subscribe to this channel. My name is Daniel and I will see you in the next one.